So welcome everyone. This is Intellectus Statistics Quantitative Analysis Workshop. My goal is to help you actually figure out how to use the tool, go over some basics, use the tool, be able to conduct your analyses and have that interpreted in APA format in pretty short order. So that's the goal of what we're doing here. If you do not have data, you can follow along. No problem. And we have example data sets that I'll show you. And if you have, as Melissa just stated, if you have questions, please put it into the Q&A. And Melissa and Ashley will happily answer that, or they'll give that question to me. And it does take some people getting on Zoom. Unfortunately, they want to update at the same time. So I like to give folks just another minute to do that. So we will do that. In the meantime, let me just put out the question. First of all, are you faculty or students? So I'm just kind of curious what that looks like. And also, I typically go over basics, levels of measurement, and what an IV and DV are. If one person wants that, I'm going to go over it. If nobody wants that, then I'm going to skip over that and get right into the tool and show the stuff. So if you want to weigh in on that in the Q&A, that would be fine as well. Whether or not you need a review of levels of measurement and of what an independent and dependent variable are. So, and I think that's probably going to kick us off there. And I will get the go ahead to proceed on here. So my name is Dr. Jim Lanny. I'm the CEO of Intellectus Statistics and Intellectus Qualitative. We have a qualitative tool, and these tools this has a little bit of AI in it. The qualitative tool has lots of AI in it, but we're here to talk about quant. So that's what we're going to do. And so the basic agenda is, if you need it, again, happy to do this, talk about what an independent variable and dependent variable are, what levels of measurement are, and why do I want to review that? Well, depending upon the levels of measurement and what your variable are, that's going to help dictate which statistical analysis test to use. So what drives the test is really the phraseology in your research question. Are there differences? Does this impact this? And so forth, and the levels of measurement. So those are really important things to make sure that you know. Then we'll go through creating an account and give you all a moment for that. I presume everyone has got a link to that to get that going. How do we set up data in Excel, from Excel? And then do some analyses, how to download, and then questions and answers. So I think with that, Melissa, does anybody want to see these levels of measurement?
No one has said that so far. If anyone wants to see it, please just let us know in the Q&A and we'll go through it.
Yep.
Yes.
One yes. Okay. So, all right. So levels of measurement, really, we break it down into three buckets. One is nominal. It's Latin for a name only. And it's got that Venn diagram sitting here, which is basically just names of things, okay? Male, female, Republican, Democrat, Independent, Coca-Cola, Pepsi, or whatever, okay? There's no ranking going on. These are just different names of groups, okay? All right. Then we go into ordinal, and ordinal just means ordered data. What is ordered data? Small 8-ounce Coca-Cola, regular 12-ounce Coca-Cola, big gulp, 32 or 64 ounces. I don't even know what they are. So then they're much larger. So you have an order, but they're not, the distances between them are not necessarily the same. So between the 8-ounce and 12-ounce, obviously you have 4 ounces. Between the 12 and the 32, whatever that is. So they're ordered, but they're not the same in between. The intervals are not the same. Horse racing, horse comes in first, next horse comes in second later, next horse comes in 30 seconds later. So again, ordered data is in order, okay, and but not equal intervals. And the icon for that is this kind of this bar chart with different levels there. Okay. The third level of measurement is the scale variable, and scale is really, it's also called interval or ratio, but basically, and the icon is the ruler. So it's it has names, great, okay. It has order, great, but it also has equal intervals. So, someone that is, 5 years old to 6 years old, there's 365 days. From 6-year-old to 7-year-olds, 365 days. From, 95 to 96-year-olds, 365 days. So the years are named, they are ordered, and they have equal intervals in between those from year to year to year. All right. Okay. And then I belabor the point by showing you some of the different, just to, again, maybe belabor, fruit, different levels of measurement, nominal levels of measurement, no differences between them per se. They're all fruit as the variable, but just named different. Ordinal, another, activity level, sedentary, moderately active, very active, what is the levels between them? This actually has some implication for Likert type items. You go from strongly disagree to disagree. Is that the same interval as disagree to neutral? So there's a whole controversy about this, okay? And, do I treat Likert type as ordinal or as scale variables? So the rule of thumb is if there, it is an article that I wrote on statistics solutions. If you, and maybe Melissa can find that and put that into the chat. But basically, if you have 3 or 4 levels there, like I do here, sedentary, moderately active, and very, keep them as ordinal. But if you have 5, 6, or 7, then you could treat those as scale. And it's important to know that because of 2 things. One, if you have a scale variable, I can start creating a score, okay? All right, that's one thing. Okay. So this is ordinal. Scale, temperature, again, from 10 to 20 degrees is equal intervals between 10 and 20 as there are between 20 and 30. Okay. And maybe just ask a question there. So let me just stop. Is there any questions about levels of measurement? Typically I just go on, but I'm like, maybe we should just pause for a moment here and ask the question. Any questions, Ms. Moran? Pardon?
No, there's no question for everyone. If you do have questions, just put them in the Q&A section.
Got it.
But you can move on.
Very good. So, all right, the next basic is the type of variable it is. Is it an independent variable, a dependent variable, or a covariate? Okay, so 3 types of variables. So what's an independent variable? So this is often something that the researcher dictates. I want to study the time it runs, the time to run a 5K by gender or by sex, okay? So the researcher is saying, I'm selecting the independent variable. I want to see it by gender, okay? So that is often a researcher dictated variable. A dependent variable is going to depend upon the subject or the object or the participant. So the time that it runs is actually the runner, the male or female running the race. So that time is dependent upon that participant, okay? The independent variable is what I want to look at it by. So I want to look at run times by gender. So dependent variable really depends upon those individuals. This was just the looking at energy levels, or you can look at it by sugar levels. This is not empirical, by the way. This is just as an example that, you know, I get to select the type of fruit I want to assess the sugar levels in, or whatever. The actual fruit is dictating how much sugar is in a banana or an apple or an orange and so forth. Covariates briefly are things that you want to control for. So I want to see if there is differences in run times by males and females. Fine question. But you notice all of the men are older and all of the women are younger. So maybe the runtime by gender is really more of an artifact of age, okay? So a researcher may say, I want to control for the age variable, okay? That is, neutralize the effect of that, and then see, are there differences on runtimes by gender, controlling for the covariate of age. All right. So now's our time to log into our account and open this up. Okay. So, so what do we have here? So for those that, I think somebody probably tried to sign. I think, let me just log into another account real quick. Nope, I don't see any data over here, but because somebody sent me their code book, but I don't have their data. So let's get logged in first. So Melissa, maybe you want to, or Ashley, want to talk about, I presume that you're getting into, you have instructions to log in.
Everybody got an email with instructions, and then we just put the login link in the chat, so you can click that and log in if you don't have the email. And then if you sent over your code book, please also share your data, and there's instructions in the email on how to do that.
Right, and since this is a workshop, I really do want to encourage everyone to load up their data when we get to it. But the first step is let's get logged in. Okay. If anybody needs more time, just raise your hand. Otherwise, I'm going to carry on here. So if you need an extra few minutes to log in, just let us know.
And if you have any questions about it, just put it in the Q&A and we'll respond.
All right. I'm going to assume everybody's logged in. So let's go to talk about how to upload data. So the first step is we're under the projects tab. We can go to upload data. And when you click that, you can upload data from different file formats like Excel or other CSV or other platforms. So you can just click on that. I'm going to go ahead and choose a file. Okay, once you select your file, you can go to upload, and it takes just a second. So what I want to show is a typical Qualtrics, if I can get to it. Trying. All right. Okay. So a typical Qualtrics survey might look something like this. It's got different rows of headers, like question number, the full-on question itself, perhaps levels of measurement of that. Ditto for these. The like or type items here might have just the labels in there, strongly disagree to strongly agree. You might have an open-ended question. So that would be very typical. As it turns out, I will say a good 95% of the job, 95% of the job is really cleaning the data. So what we've done is really create a data cleaning wizard. And I just want to kind of go through that to show you how kind of get your data set up. Because once your data is set up, results are 2 minutes away. So, but let's get that data set up. So if you're using a data cleaning wizard, you can get rid of those extra rows of headers. That's one thing. So I don't need those, but I know this is age and sex, and then my variables. So I'm going to apply changes and go to next. Then I'm going to change some variable names. So this was age. Okay, this was sex. At birth. Okay, and then those I'm just going to leave the way they are. I'm going to apply those changes. By the way, that's really helpful. So should you have the whole question as your variable name, that's going to make the tables look terrible. So, and everything else. So even if you have to change your, that whole K3 pre question to a K3 pre. So keep it short just so you know what it is. Okay. All right. We also have misspelled variables. So even in Qualtrics, sometimes you'll come up and you're asking about sex, and they'll say, have male with a small m, male with a capital M, disagree with 3 E's or with 2 E's. It happens. So what our AI tool does is it picks that up and it says, I want to merge these, because you can have a problem later with other analyses and composite scores if you don't do this. So if you click this button, it will show you what it was before and what it will be after. Basically, it merged those disagrees with 2 E's and 3 E's. Okay, so I can just merge and apply changes. Do that for the next variable, merge. You can see the before and after, apply changes. And there's no more misspellings, I go to next. Okay. If anybody needs more time, just raise your hand.
I think they're good, and there's 2 people that have their projects shared with you. So when we get to that point, we'll open those up. Yep.
Wonderful. All righty. So very often people have surveys that they need to create a subscale or a composite score. I use those terms interchangeably. So yes, I do have a Likert or Likert type scales. So I happen to have a 5-point agreement scale. And basically I have these labels. I need to change those into numbers because I want to average those. Okay. So what I can do is, so I've selected one of these types of scales. I agree that that's happening there, and I want to change all of these guys' labels into numbers. So check all, apply changes. Okay, great. And then that takes care of changing things from labels to numbers. And then go to next. Okay, add subscale. Yes, I do want to add them. I want to create a pre-test subscale and a post-test. So you have to name the scale. So I'm going to say pre-test. You can either average them or sum them, unless the directions of the scale says to sum them. I prefer averages because I understand a 1 to 5. If everyone's at a 4, or the average is 4, I can say, hey, you know what? They tend to, on average, they tend to agree. All right. I understand what a 4 is. But if I have a 20, well, they get an average of 18 out of 20, I'm like, what does that really mean? So averaging, when you know the range of scores, is helpful. So I named the pretest. I'm going to average them. I put the variables in. Okay. And you can reverse code right then and there too. When you do that, you have to put in the min and max. So what does reverse code mean? Well, some questions are asked in the opposite manner. So let's just say I'm assessing happiness. And I'll say, how happy are you at 9 a.m.? How happy are you at noontime? Are you unhappy at 2 o'clock? Okay. Asked in reverse. So to get an average of happiness scales, I need to have all of those numbers in the same direction. That is to say, high numbers in my example mean happy. Low numbers mean unhappy. So that's what a reverse coded item is. So once I have those items, I've named it, I'm averaging them, I've identified them, I've identified the reverse, and I've identified the range, 1 to 5 of that, and just apply changes. And we're going to do one more. So I'm going to call this post test. I'm also going to average. These are items. Notice that there's a new score there called pretest. Put the range in. Okay, apply changes. Go to next. Okay. I'm almost finished. An ID variable, it's not a bad idea to have that. If you had not a 4, but a 44, you're going to want to say, you should number the number the surveys, and be able to go back and reference those in case you have a data entry error, for example. And then I'm finished. So, and just hit continue. I should note on most of these boxes that I'm going to show you, there's a video tutorial built in. So you don't have to Google around. You can kind of get there.
Can we
Okay.
have 2 quick questions about this section if you want to go to the Q&A?
About the section?
About the data cleaning and reverse
Okay.
coding and things.
Yep. Let me find my, where is this? My Q&A. Hang on. Okay. How do we integrate Likert scales in this level of measurements? Well, that's what I'm doing. How do we integrate Likert scales in this level and in this level? I don't understand what that means. How do we integrate Likert scales?
Diana, if you want to just add more to kind of expand on your question, and then if you
Please.
can go to the next one.
What if you already have reverse coded the items in Qualtrics prior to adding data to the platform? Perfect. So you're just going to just add them. So when I'm adding up, K1 pre, K2 pre, K3 pre, K4 pre, then all I do is average them together. If it's already reverse coded, you don't want to reverse code a reverse coded item. So so just add them together, average them together. I am curious if Qualtrics does that for you. So I'm curious about that. How that happened. All right. Okay. So just to clarify, if you're using Likert scale to choose scale, not ordinal, correct? Very good question. So right. So once we we did have these as labels, right? From strongly disagree to strongly agree. We definitely want them as scale because we cannot average them as ordinal variables. So that's correct. So that's a great question. Oh, I had to manually reverse code them. Yucky. So yeah, use the data cleaning wizard. Okay, so there's only 2 other things I want to do here, and then I'll probably just jump into real projects. So the 2 things I want to do here is, age was really, it came in as numbers. So some things we want to move from labels to numbers. Some things we want to move from numbers to labels. So with our Likert type scale, we have labels, strongly disagree to strongly agree. We need to put them in numbers to generate those subscales, pre and post tests. other things come in as numbers, but really they're labels. So age was really an ordinal variable, and I can just, what I did is I just clicked this caret down, clicked on ordinal, and then I can just type right in there, okay? Oops, well, fine. Okay, and then I can put that right in the same variable. So I'm changing from those numbers, okay, into the actual labels, and from scale to ordinal, which kind of gets around a few things here. So must reverse code be 2 or any number? Not sure of that question. Sorry. So must reverse code be 2 or any number? I don't know what that means. I'm sorry, Martin.
And Martin, you can also just expand on your question in the Q&A and we can get back to it.
All right. The other thing I want to do to kind of clean up, but the data set's getting pretty clean, is that I have this open-ended variable that's asking about leadership and transformational leadership. Well, I can read through these 20, but if I have 200, okay, a little messy. So to get a little step here, I can go to under data management, text classification. And what this does is it's going to take that variable leadership. You could manually identify the number of categories, but automatic uses AI and some statistical analysis. And what it does is it helps bucket those responses. And what it's done is it's actually bucketed those responses into 4 types of buckets, either dealing with ethical leadership, interpersonal communication, metacognitive skills, or transformational leadership. The benefit of this is not a deep dive into qualitative, but now I can start interacting with their open-ended responses with other variables, be it pre-test, post-test, be it age or sex, and so forth. All righty. Let's say a couple more things and we'll get to projects. So we've moved right into the data management. What was just accomplished could also be done manually, so to speak. You know, there's a variable calculator here, okay? You can do that for each one of them to create a composite score. You can recode, you can reverse code here, items, okay? You can recode multiple variables, okay, into different levels of measurement here. So then one important thing in the data management is the download data. So I want to download, because currently I want to download my managed data, which have my buckets as well as my subscale. So that's really important. There's different plots to be had. Very simple to use. Do you see our friendly icons here? Right? Ordinal, nominal, and scale. Okay. So if you don't see your variable here, well, maybe it has a different level of measurement there. So just heads up on it. Videos. And then you can kind of see what's happening here. Hey, gosh, 60 to 69-year-olds had a lower pretest score, and everybody ended up about the same. We'll get to the analyses in a moment, and does everything from descriptives to structural equation modeling down below. Also, there's a few other things. There's a decision tree to figure out what tests to use. So the typical mode is to walk across these branches. You'll notice that we're asking about IVs and DVs. So I can say, well, I want to predict an outcome. that scale, I'm doing a linear regression. I could also use this kind of layperson questions up here. I want to predict an outcome that scale. I'm doing a linear regression, conduct analyses, and I jump right into it. So to figure out what test is important, mostly in your methodology and mostly in your IRB application, they're going to want to know, what are you doing? Well, I'm doing this test. They're also going to ask you, what are the assumptions of that test? Well, under data analysis plans, you can click on the particular test that you now know, and you have a data plan laid out that's downloadable, editable. IRB and your methodology is also going to ask, what's your sample size? Well, you go to power analysis, select the test, and this is for one predictor, but you can change these things. And this, so just know that there's some questions up top, perhaps. And you have a very quick way of assessing sample size, 4 different effect sizes, 4 different tests. Hopefully that makes sense. Okay, and that's also downloadable and editable. So I think with that brief overview, I just want to say that there's also a video tutorial sitting here. It's a 200-page manual here. We have courseware, it's like $5 a course here. By the way, for all the faculty that are out there, we do have happy to get you longer term demos and courseware to review if you would like. And it comes with free faculty training, and love to train on your actual data. So we're actually being productive and learning to see how the tool works. Okay, with that being said, let's go to the other data set, which probably has, okay, lots of projects going here, yippee. Okay, dismiss. Okay, so accept. We'll see how many we can get to. Okay. All right, so let's get, yeah, thanks for putting in the, Ashley's information is in there for those faculty that want that. Ashley's very nice, by the way. She's happy to get your email. Okay, so let's get with Erin first. So let's see what's happening here. And maybe we can get Erin unmuted.
If you could just raise your hand, it'll be easier to find you.
All right.
There we go.
All right, so hi, Erin.
Hey, it's Tanya, actually, sorry.
Oh, Tanya.
We share the account and she's not here, so I'm sitting in on her behalf.
Well, whose data is this?
This is my data though.
Are you sure?
Yes, 100%.
All right, fine. All right, so you're going to give me the opportunity to, you have pre-surveys and post-surveys. So we need to just do,
yeah,
correct?
yeah.
Okay, so we just need to do, and then these people didn't fill it out. That's very common. All right, so basically we probably want to do like 3 things. We want to change those into numbers. We want to create composite scores that we just did. We probably want to do descriptives. Let me just take a moment there. Everyone should do descriptive statistics. Everyone. Why? Because if you have a data entry error, you want to find out before you go conduct your analyses. Otherwise, you go back, then correct your error and redo everything. Okay, took me 10 years to learn that, maybe longer. So run descriptors on everything. But we just basically did all of this. Do you want me to do this, or do you think basically from what we just did, you can do this?
I can do this, I think. And I actually uploaded another one where I manually, like an idiot, added numbers to everything because I was just a little concerned because all my questions were negatively worded. So I didn't know the reverse coding feature. So I manually went in and added, like, so agree would get the least number of points.
Right.
because I wanted, it's basically, the questions were worded negatively for all 4 questions.
So is this, have you reverse coded these yet or not?
No,
Okay, so let's just go ahead and do this, okay? Let's just do this. So let's just get them to numbers. It looks like a 3-point scale.
it's 4.
Okay,
5,
so I have,
5, sorry, 5-point
it
scale.
is 5, strongly agree. Okay, so let's first of all, let's just show you quick ways of doing this. So first, we're going to recode multiple variables. We need to check all box. Okay, so that's my note to my programmer. Oh. So we want to change all of those into scale, okay?
Mhm.
Then I want to put these in the correct order, which
Okay.
is strongly agree, blah, blah, blah. Okay, good?
Yes.
Okay, then we're going to turn, well, by the way, since we have to reverse code them, heck, let's reverse code them right here.
Okay.
1, 2, 3, 4, 5. And I'm going to put them in the same thing. Submit. That's step 1. And we've reverse coded, turned them into numbers. Now just create those composite scores. Do we want to average these things or sum these things?
We can sum them. I mean, will it
That's fine.
matter? I don't know.
There's 4 of them. So I like to average them, as I said, because
Mhm.
you can have a score up to 20. If you have a 17, what does that mean?
I don't know.
Not quite sure. It's somewhere in that agree. So if I average them,
Okay.
okay, let's get a mean composite. If I average them, 1, 2, 3, 4, you can see pre, okay, submit. Okay, let me just do real quick with the other. Post. Okay, mean composite. Okay, voila. Now let's just run descriptives as I suggested,
Mhm.
mostly just on the pre and post. Okay. So I just went to descriptives.
Okay.
Okay, and then I just went to add modify, and I put in my 2 variables of interest and hit confirm and calculate. Now let me ask you the question again. Your
Mhm.
scale goes from 1 to 5. What does a 2.5 mean? 2.4.
Oh, yeah. Okay.
Just smack in the center. You can't
Yes.
really
That
not
makes
neither
sense.
agree nor disagree. Now you know.
Yes.
What does a 3.69 mean?
A little on the higher end.
Okay, you're between neutral, either
Yes.
disagree and agree.
Okay.
Now you have some sense of it without having to do stuff. You
Okay.
also want to look at the min and the max
Mm-hmm.
to make sure, hey, I had a 1 to 5 scale. Nobody should have a 6. Nobody should have a 0 or
Mm-hmm.
0.5. Okay. Then we want to just basically do a pair t-test, right?
Yes.
We want to see if there's differences from pre to post. Are you faculty?
No.
No problem. So pre to post, and basically, so here so one advantage of this is the assumptions are built in. One assumption of a pair t-test is normality. It identifies the test, it
Mm-hmm.
runs the test, and interprets the test. Okay. We also can see that was significant difference between the pre and the post.
Awesome.
Was significant. It is awesome. A significant difference. The mean of pre was significantly lower than a post. You could also say it in the opposite. The mean of the post was significantly higher than the pre.
Mm-hmm.
APA table, helpful scroll over, appropriate plot. One quick caveat that when an assumption is violated, the non-parametric equivalent test, that is to say, a test that looks at pre and post, but without the assumption, it's called the Wilcoxon. Here, there are also differences. Okay, and then here's the plot and scroll over.
Okay.
Okay, one other caveat for everybody. we've templatized this so you just don't stick it in your paper. So this right there is published with Turnitin. So you need to put it in your own words,
Mhm.
put it into ChatGPT. You got to get that out of there. Otherwise, it's going to be flagged, okay? All right, we good to go, Tanya?
Yes, thank you so much. I appreciate it.
Come back to us for discussion chapters. We can help.
Okay.
All right, so let's go to the next project. Okay, so TAE Medform, I guess raise your hand. So what's going on here? Okay. All right. Okay, who do we have here?
If this is your project, can you raise your hand, please? I don't see any hands raised. Do you want to maybe go to another one that's shared with you?
Yes, we have a phantom data set. This might be. All right, so for sure, for all of these things, you want to, again, run descriptive statistics, okay? Just to make sure that everything is cool here. All right, looks like an interesting data set and take it from there. And okay, all right. General example, is that our general example?
Nope. Or
So
I don't know, actually.
we're gonna find out. We also have a thing called general example. It is. Okay, so I'm probably gonna pass on this, unless you have a specific question about this. Or you uploaded a data set by accident. So I think I just want to sally forth here. Okay, and then let's just get to NCAA. Okay, NCAA, come on down.
Okay.
Hello,
Hey,
Amanda.
that's me.
Hi there. Is this your data set?
It is a secondary data set that I am working on cleaning up for a class project.
Okay, and you student or faculty?
Student and staff.
And so, okay, all right, fine. All right, so the first question is really, what is the research question or what is the study aim?
Yeah, so we want to look at, is there a difference between individual and team sports APR data? And this is all from the NCAA. And so what's not in here right, APR, yeah, academic progress rate.
Oh, okay. Okay, so, okay, and then, so we have lots of different APR data.
Yes, I've cleaned up actually a lot of columns so far, but really it's giving you years, academic year. So the column C is 2019, 2018, following that. So each year it gives you what the APR rating is for each school and which sport. So currently I don't have them coded by individual and team sports in this document, but that would be like the next step. So feel free to like manipulate however makes sense right now.
So check it out.
example.
So I can go here, okay? And I can go to manage. And I can start merging. So I'm going to go baseball. So baseball, basketball, football. Track is that single or group?
It's individual.
Okay. Except for that little baton thing, no? All right, fine.
I know. There's always exceptions.
That's what I'm asking. Okay. So basketball, okay. Bowling, okay. Cross country, skiing, single, softball, okay. Soccer, tennis, same, okay. Cross country, volleyball, men's soccer. So we're doing groups, golf, volleyball, mixed rifle, interesting, okay. Ice hockey, group, men's cross country, swimming is individual, rowing, that's a group, unless you row by yourself, gymnastics, individual, swimming, individual, men's wrestling, women's lacrosse, group, water polo, group. Boy, do you have enough sports going on here? Okay, then volleyball, polo, gymnastics, field hockey, men's skiing, looks sounds individual, women's skiing, men's lacrosse, men's fencing, women's fencing, ice hockey. Okay, so I think that's one group. I
Yep.
may have missed some, but let's just merge these and let's merge them into what do you call them, group?
Team sports.
Oh, team. Thank you. All right. Then all these other folks should be individuals. So golf. Okay, so blah blah blah. Okay, is that good?
Yeah, that's great.
Okay, merge. Okay, and then individual, correct?
Yes.
Okay. All righty. So, and I'm going to put them in a new variable because you may want to keep them separate at some other point, okay? So, append new variable. And then really, okay, so a few things here. So let's just run descriptors real quick because I can't be giving out advice and then not following my own advice. Okay, so check all. Okay, sure. So here's all the schools that you have here. So a few of them. How many schools you got here? 6,000?
That is definitely the amount of rows I had, but it was not the amount of schools.
Okay, are there more schools or less
No,
schools?
that's all of them. So each school is broken down by row by their sport. So
Fine. Okay.
I'm gonna guess
I
like
see. So okay. So I see. So there's going to be fewer. So you had team sports 3,000, individual sports. It's interesting that there's about equal amount of team and individuals. Okay. Me at least. All right. And then you can kind of get a look at what's happening here. So mins and maxes. Okay. So somebody's got a low score there. Max is 1,000. All right. And the mode is 1,000. So what does that mean? So the most frequent score for this for these is 1,000. Okay. When you look at differences, so let me just give a heads up here. So here's my guess. Basically, you have a range of scores from 982 to from 714 to 1,000, but the most frequent score is 1,000. You may not find differences between individual sports, between sport, group versus or team versus individual, because everybody's at the ceiling. But let's find out. So you can just take one of these by what kind of test should we be doing there, Amanda, who's in class?
I'm honestly not even sure.
Okay, let's figure this out. So I want to examine, so in your question, you were very astute to say, are there differences? So
Yep.
Want to explore differences between groups. And do I have more than one dependent variable? For the moment, let's just say we're taking 1 year, okay? So we'll say no, we only have one dependent variable, 1 year scores. No covariates that we're talking about. More than one independent variable? Nope, we just have team versus individual. Do you have more than 2 levels? Nope, we only have team versus individual. So that brings us to a t-test. So we are conducting, Amanda, an independent sample t-test, okay? And then I can go into that dependent variable. Let's just pick 1 year. And then we can go into the independent variable, which is our sport name. Really, we should have changed it to, binary variable. So we're looking to see if there's differences there by team versus individual. There's assumptions associated with it, which happen to be violated. There's assumptions that are violated. It's kind of surprising. Okay. So there is a statistical difference between these, and you have individuals have higher scores statistically than team sports. Okay. So here's a caveat for you. So if you're happy, don't be so happy, because what's going on here? They have, a mean of three more out of 1,000. You have 3 higher. Okay. So what's going on is that when you have large samples, as you have here, okay, that small differences are statistically different from each other. Okay. So my assumption was wrong that my assumption was correct that they're all at the ceiling, 981, 984, pretty darn close to 1,000. Okay. You have a statistical difference, but what you really want to look at here is the effect size. Okay. See that D? That says how important are those differences. That ranges from, I don't know what D, I think you can go on, but I think a D of 0.3 or less is a small importance, a small effect. 0.3 to 0.5 is a moderate effect, and above 0.5, and it can go to 2.5, okay, is a strong or large effect. So the statistical differences, but I think the real story is here with the effect size. Not that important, that difference, okay? And you can see, again, an average of 3 more out of 1,000 is nothing, okay? And trust me, if you had, let's pick a school. Let's pick a school here. If I pick a school that has, let's just say, well, let's pick a school, Washington State University. Let's do the same darn thing, okay, with a new analysis, but I'm only gonna use Washington State University. Sport. Where's my school name? A CL name right here. Okay. And this Washington State. I may have passed it. Sorry. Just pick one. No, I'm sorry.
I think they're alphabetical by state. At least that's how it was when I pulled the tab.
Okay, so let me go to the end. Well, let's just pick one. Pick one that's relatively large. Okay. So just to exemplify, hopefully there's enough in there. So it's going to be much smaller sample size. So normality, homogeneity, variance. Okay. Basically, this is a difference of an average of 6, right? From 984 to 990, that's 6 points. Not even close to being significant. Okay. It's a sample size of 14. So that sample size, and that large sample size is revealing statistically significant differences. By the way, that effect size is much more, it's still small. You would do the significance level, then look at the effect size after that. But you can see for a larger difference, it's not even close to being significant. So the sample size is driving the significance. Look at the effect size, and you can do that for every single one of them. Make sense?
Yeah, thank you so much.
My pleasure. All right, who else do we have here?
Do you have one shared that's says a metformin data set? That one.
Okay.
Yep. Can you
Do we
open
not
that
do
one?
this? Okay, who do we have?
Nanette?
Hi, Nanette.
Oh,
How you
Hello.
doing today?
I'm good.
Good. All right, what are we doing here? What's the research question here? That's the better question.
Looking at the effect of the vitamin B, the thiamine level
in regards to diabetes or no diabetes. Unfortunately, had a really small sample size.
Okay. So you have the opposite problem that we just dealt with,
Yes.
okay. And then diabetes. Okay, so, um, so I want to wordsmith you a little bit, because I liked the earlier call, Amanda, that, you know, we are looking at the effect of it, but technically speaking, statistically speaking, we're really seeing that there's differences on vitamin B by group.
Correct. Yes.
Versus not, okay?
Yes.
Because that's going to drive a different test. Now, the effect of that presumes a regression equation. What is the effect of this on that? Does this predict that? Does diabetes group predict that? So, but I would look at differences to start with. And then I saw that we have small things here. So let's just go to a independent sample t. Well, wait, let me ask the question. Vitamin B, how is that measured?
It was blood.
Okay, so do I have like a scale variable?
A number. Yeah, it's a
Like
number,
this?
the scale.
Okay.
No,
Perfect.
it's
Well, what is the you'll show me. All right, so here, so let's just run descriptives first. Okay, on group, and then where is my vitamin B?
the blood measure thiamine 21.
Thank you. Okay. Just to peek at what's going on here. So you show your small sample. By the way, that's not the worst thing in the world. I mean, we're not quite Freud.
We desperately tried.
Like one, but
We tried.
I know it's not easy. So, and then you can see the range 72 to 218. Does that seem reasonable?
Yes.
Got it. Okay, cool. So now we can look to do an independent sample t-test. We can go to our blood thiamine. We can look at it by group. So I selected the test. We put in our dependent variable, which is what depends upon the participant, what their blood level is, their vitamin B level is. The researcher selected the independent variable. I want to look at it by group, but you could have said by other things. Okay, so assumptions. So again, it's assessing normality with Shapiro-Wilk. It runs it. Assumptions met, hunky-dory, both of them. They run that on each group. That's surprising, by the way, that with a small sample, typically sometimes it's not normally distributed. So everything's hunky-dory here. No difference statistically. No diabetes. Higher levels of that than diabetes. If you go back to the case we just had, if you had 6,000 people, not 24 people, that would be significant. So you have to put these things in context. That doesn't make sense, you know? But for this sample, is this in the direction that you wanted to see it, by the way?
Yes, yes, definitely.
So that's something that you can, a student or faculty?
Faculty.
Yeah, so you can say that, hey, you know what? There's no cigar here, but it's in the right direction. And you know, the effect size isn't the best in the world. And then say it's, you know, hey, you know what? Maybe we do want a larger sample based on this, I'll say trend or higher differences of no diabetes. Excuse me, higher vitamin B for no diabetes compared to those with diabetes. All right, you want to peek at something else while we're at it?
We did see a correlation using the Pearson with the hemoglobin level and
okay. So Pearson correlation sitting here. And which one are they?
The hemoglobin 22.
Yeah, I like that you number these things, by the way, too.
And
it makes it easy to read.
Yeah, thank you. And the thiamine.
And 21.
The 21. There we go.
Right. So, so with all of these test assumptions are built in, the scatter plot, I guess you don't want to see curvilinear or that kind of business. So very strong effect. So correlations are effect sizes essentially. So these
Okay.
are identical. So 0.64, anything over 0.5, strong effect. And it's positive, which means as hemoglobin increases, vitamin B increases, or vice versa. So there's 4 ways to say that. As hemoglobin increases, vitamin B increases. As vitamin B increases, hemoglobin increases. As hemoglobin decreases, vitamin B decreases. As vitamin B decreases, and vice versa. The other, so down, or up. In any order. This is for other folks on the call to say there's 7 ways of saying it based on the story you want to tell. What I did not share with others is the downloading of this. And when you download these documents, by the way, I'm happy to, you know, to put your information into to Ashley, and happy to drill into other things. But just to show other folks what you get in the output document, you get the analyses that were done, the descriptives, which I harp on, t-tests, okay, correlation. But what is also here is APA style references for all the in-text citations.
That's nice.
That is nice. It just saves a step. And then there's also a curated glossary of the terms and symbols for each of the tests that were conducted, for descriptives, t-test, correlation. And then we also have some raw output, which has a little bit more information than what's in the write-up. I will just mention too, though, that we also have courseware for the quantitative. So under Intellectus Statistics, so this courseware can go behind your LMS. It's competency based, so you get grades to your grade books. And then there's all different kinds of lessons, and faculty can just kind of package the lessons that they want to teach. We put it behind your LMS. Everybody gets a PDF as well, and they're very easy to use, and they're user-friendly in terms of from the student's point of view. So just to say that there's courses too. Let me also add that there is a qualitative course. I know we're here for a quantitative workshop, but just to know that there is a qualitative tool, and you can look at that under Intellectus Qualitative. There's courseware. AI is infused throughout the whole darn thing, and just to know that that's there. So just to put a plug in for that. Okay, so other, Nanette, are we good, or do you have anything else at the
Yes,
moment?
thank you. No, thank you.
My pleasure, my pleasure. Okay, so other questions, or let me see, there's new. Okay. Any other final questions? I hope this was helpful for folks, you know, to get some fluidity with running your analysis.
If you have any questions in the Q&A right now, we'll send the recording of this to all of you via email, and it'll be posted on our website. And then again, reach out to Ashley if you want to learn more about trials or things like that.
And I should put here, so let me just do this. So let me just do slideshow, current. Let me just switch this over just to kind of wrap this up. Oh, evidently I don't have a, okay. So I don't have the contact information. But let me just do this thing here.
And we put it in the chat.
Okay, I was gonna put it just for people to watch it, but that's fine. So it's just basically Ashley at intellectusstatistics.com or 727-380-3982. Okay, final questions, final thoughts?
I
All
don't-
right,
You guys can email us if something comes up later. Problem.
say it again, please.
Feel free to email us. Questions come up later, give us an email, and then this is every first Thursday of the month. So you can register for the next one as well if you'd like.
And share it with others. If you know other colleagues, faculty, students that can use it or are upcoming with analysis, please share that. All right. Another workshop in the can. So thank you all so much for joining. And again, please share with everyone and have a great rest of the week. All right. Bye all.